Hello students. In previous videos, we had equation for charge, second order differential equation for charge in series LCR AC circuit, and then in second video we had equation of complex current for the same circuit, LCR combination and AC source. In this video, we have equation of complex current, but only for series combination of resistance and inductance. So the question is, write expression for complex current for AC circuit with series combination of resistance and inductance. Draw graph of current versus time and voltage versus time. So from previous equations, we'll find out how much is the current if we have only two components, R and L, and then we'll see how current varies with time and how voltage varies with time. Okay, so let us start. Uh, Before we go to RL circuit, let me recall equations from previous video. We had V is equal to Vm e raised to j omega t. Remember that actually it is Vm cos omega t real part plus j Vm sin omega t as imaginary part, but imaginary part is not considered anywhere, so we will not be using it. Similarly, I is Im e raised to j omega t minus delta. This was the equation which we derived last time, and what will be the real part? It will be Im cos omega t minus delta. Imaginary part is j Im sin omega t minus delta, but as I mentioned, will not be using this part. To plot graph of voltage versus current and voltage versus time and current versus time, we will be making use of real part. Okay. Moreover, we had one more equation of Z impedance, which is given as R plus J omega L minus 1 by omega C. So if I label this as equation 1, 2, 3, what right now we have is RL circuit, means series combination of R and L connected to source of alternating voltage. So all I need to do now is I just need to first find out Z for this circuit. How much is the Z? There is no capacitor, so I can write Z for this circuit as R plus J omega L. How do you represent it on complex plane? So we can take real part on real axis, imaginary part on vertical axis, imaginary axis. So real part is resistor. Let me take it here, R. Let me assume this is omega L, and then this becomes our impedance, and here is the phase. So then if we are asked how much is the modulus, how much is the magnitude of mod Z, we can say it is under root of x square plus y square. Here it is r square plus omega square L square. And how much is the phase of this impedance? So we can say that phase tan tangent of delta is opposite side, that is omega L by adjacent side R. So this is the phase, here is the magnitude, and then uh, we can write equation of current as V is Vm e raised to j omega t, and let me write real part only. So V is Vm cos omega t, and I is Vm by mod Z cos omega t minus delta. Remember what is Im? Im is Im is Vm by mod z, maximum voltage by magnitude of impedance. So once I have mod z defined, I can write current as shown here. And now, how do I plot this? So if the variation in voltage is presented as this, because it is function of cos, you can present it like this. How do you represent current? Because see, voltage is function of cos, current is also function of cos, but voltage is function of cos, current is function of cos. Both should start from maximum, but the voltage is having phase omega t and current is having phase slightly less than omega t. Okay, it is omega t minus delta. So what does it mean? What it means is that if voltage is being 0 here at this time, current will be 0 after some time because phase of current is less, maybe somewhere here. If voltage is again being 0 at this time, current should be reaching 0 after some time, and that is true with peak value also. If voltage is arriving at its peak at this time, current should be reaching its peak after some time. Okay, maybe somewhere here. So when I plot the graph, I should take care of that thing. That graph should look like cos. So I'll start with maximum, but I should be careful that the zeros of voltage and current are not matching, and so as the peak. So this is how I can show the difference. Uh, Let me show you again that this is this difference is determined by the factor delta. More the delta, more the difference. Okay, so this is the graph of current, and this is the graph of voltage versus time. So that is the topic. I hope you could understand. Thank you.